So when you're going first, the first important thing is you need to go for the planning activities with respect to your software development. Here it's not that your software alone is going to play a vital role, but even you should also understand what is the system development what you are carried out. Okay, and how you are going to integrate that system and how you are going to test that system along with that software development what you have. Those planning activity you need to do. So this is a V cycle we have seen, and this V cycle is been applicable very much important with respect to the planning of the software activities. So here I told you about the software safety requirement. It can be the safety requirement or a function safety requirement. And again, here since we are going for a planning of software, so we need to go for a software safety requirement. And this is based on the verification what you have with respect to the particular software safety requirements. Same is applicable for a system and hardware as well. So where we need to follow the V safety cycle when we are going for any planning activities. And the next one will be the architecture design, which I was explaining you. And when you go for architecture design, again, you also need to get the input from integration, software integration and testing, where you go for a verification and validation. And the last important thing is software unit design and implementation, where you need to have the inputs from a software unit testing. So you need to have the level. You need to first start with the software safety requirement. Then it goes for a software architecture design. Then it goes for a software unit design and implementation. Then you go for a testing, integration, then verification. Okay, this is how you need to go for a planning activities. That's why the software development. And again, um, even here when I say planning, it's again the project plan and also the safety code. Your project plan again with respect to the time plan point of view, where you need to look for the implementation in the specified at a time, and you should also understand what is the duration accordingly. You also need to you also have different project gateways or milestones where we go for alpha level, beta level, gamma level, or T1 level, T2 level, T3 level. It will vary from OEM to OEM. But the time plan, the time requirement is very much strengthened for any of the company. So accordingly, the OEM will set a target, and they also communicate it to the developer or what you call architect of a tier one company, and accordingly, developer or a architect will also have their own time plan. Not their own time plan, which is respect to the time plan what the OEM is going to give to them. Accordingly, the planning is very much required, and they need to integrate, and accordingly, they need to give it with respect to the planning activities, and they should also ensure that all the design are being carried out without affecting the functions of the safety code. And the very important thing is the time point of view. So, as per the project plan, management, you have a triangle where one will be a quality, one will be the cost, and one will be the time. So when I say the time is very important, and even the cost is also very important, where for which you need to do the cost as planning as well. So how to consider the development with lesser cost, and even the quality aspects are also very much important. But so when I say quality, it is again the performance. What is the performance that particular software or a hardware or a system is going to develop or needs to be developed with respect to the quality aspects, and what is the expectation. So performance by expectation will give you the quality. And when I say expectation, it is again the expectation is always on the higher side. Okay, so when you have higher expectation, there is no limit for the quality itself. Okay, because customer will have the expectation which is higher level. When the customer is having high level of expectation, um, and then what happens is there is again a considerable increase with respect to the cost point of view. So again, Compromising the cost quality within the time is always a challenging task for the architect, developer, and also for OEM. That is, just give me a second. Just give me a second. But these are some of the example of software design. I was telling you about the software architecture. So you need to so this one example of sensor fusion. But there is one more case study with respect to this. But we will see that case study which I was explaining with respect to the first slide. And here, what just show you this is case study, but we will see this in a detailed way with respect to the further FTA analysis as well. But here I'm going to give the example considering the software design. So when you go for an architecture, you need to divide it into the different phases. Phases in the sense the levels, you can call it as a unit or a level or phase, whatever it is. Here they are considered as a unit. So the first unit is sensor fusion. And again, when you go for a software architecture, you need to understand what is the level of the cell category. Consider this only you are going to look for your architecture. So here that is what. So instead of SLB, when you are considering SLD, what happens is so again you will be considering all the features with respect to SLD and not with respect to SLB, and again here there will be the time as well as the cost will going to get increased. This is where the planning is very much important, and even the decomposition what you call SLD to SLB. So the minimum, the low level SL level you need to consider here. At the same time, this SLB should also meet the safety goal. Okay, irrespective of the decomposition. So when I say SLB here, I will not say what is the original SL. Is it SLC or SLD? Okay, or is it SLB itself? Okay, so when I say SLB, irrespective of the decomposition, always need to ensure that what is the safety goal, what the safety plan, what we have with respect to architecture, what you are going to consider. Accordingly, you need to consider it. And here, next will be the next phase is the main function. Again, you need to consider up to again the same as what you're going to consider here. And third one is monitoring function where you need to monitor all the things, and this considers phase 3 or unit 3. And the last one is the comparator. So here, this is where when you go for the last phase, you need to consider the original acid, irrespective of the here again. Even here, you should not look about the decomposition, but again the safety code. Let us go step by step. What are all the features that need to look up each and every individual phases or a unit. So here the test case for the main function in the second software unit are derived using the analysis of requirement and boundary values. You should also understand what is the boundary value that you have. and you need to understand, you need to undergo the test using the requirement based on the interface and testing method. So here the design and the testing will go hand in hand. So the input to the design is also coming from the verification and the validation what you have for a particular software. And again, even the testing V&V is also carried out considering the input requirement what you have for a particular software. And here we are also using the Misra C software for programming it. And so here, when you go for a sensor fusion, so what is important is the plausibility and range checks of input signal is very much important. And this plausibility and range checks of that particular input signal is also going to fulfill the SLD software safety requirement. So here, the original thing, because the sensor is very much important, and for which you need to get the signal and need to properly operate. Otherwise, what happens? This will lead to the biggest hazardous one. So you need to consider the signal with respect to the high level of SL category. And when you go for a monitoring phase or a monitoring unit, where we are going to consider the SL with respect to the low level or the, the phase where we are going to consider with respect to the safety goal. So here you also going for some of the external monitoring, and you also have some various software design which will fulfill the SLT requirement based on the software architecture. So here again, when you go for the last unit or the last phase where you have um, the comparator, here you are also going to go for uh, the triggering condition where you call it as a SOTIF, and you're also going for some of the assumption. Um, so we have seen some of the thing where we also go for assumption. So here assumption is based from the architect or a developer. Some of the uh, safety goal is not been given with respect to the OEM point of view. So here with respect to this comparator, so the architect or the developer will also assume a safety goal where they will also understand what is the quality function, which is been classified as the high level of HL. And here, um, no other safety goal are being conceived in HL here, and you need to consider you don't need to break down the safety goal, main safety goal into the various safety goal. You can have only one safety goal or two safety goal, but again, you can consider the various features to achieve the safety goal, not the safety goal getting broken down into various subdivisions. Okay. And what we are going to ensure is that we are going to have a software safety requirement to degrade a safe state in case of there is any error is going to happen. Here the seed level will be having just a second. Okay. We have seen the V cycle. Just a second. Okay. So this is the software life cycle what you have. Uh, uh, with respect to the system design, we also need to consider the TSR, and with respect to the software design, what we have considered is architecture design, software safety requirement, the software unit design. So here you need to consider the very important thing is the embedded system. When you're going for a software, embedded software, what you call, and here you need to go for a software unit testing And I told you about HSI, where you go for a hardware software interface. You need to integrate uh, software and when you're going for a verification and validation. Okay. So this is what the system level we have seen, and again, the work product what you have for a software level is also similar, but uh, here what we are going to consider is again same with respect to the software architecture design, where we are going to have specification analysis report and the failure analysis report even. So here there is a question that higher ASIL level will be having more fail safe out. So the mechanisms will be higher. So accordingly, the inputs will be taken, and accordingly the design activity is being carried out. Um, we also go for the verification report when you're going for architect decision. This is the first stage, and as I said, you should have the SR or TSR or so when I say TSR, it's nothing but technical safety requirement, and this technical is again categorized into system, hardware, and the software. So according to the context, you need to take it into consideration. So here, the software you're going to take it. So you need to consider software safety requirement as well as specification, and again HSI specification, and again what is the verification report. All these things it goes hand in hand when you're going for architecture design. When you go for a software unit design, you need to go for a specification. Same, it gets repeated. So you have embedded software, and you go for a unit testing with respect to the what even you can have the program testing what you call, and finally you need to integrate all this in the hardware and software. You need to go for a complete system, hardware and software verification and validation. Same here when you're going for a hardware level. So instead of embedded software, what you have, you'll be having the hardware. Same here, as I was telling you, the software will be replaced with the hardware here. So same here you have the hardware safety requirement where you're going to get the uh, input for your design, hardware design, and you go for a hardware design verification report, and then you go for analysis. So here the analysis is best to cope up with the random hardware failure. So you have the systematic failure as well as the random hardware failure, and even here you can consider the different failure modes with respect to the ASIL category, and accordingly you can also have the fail-safe operations or fail-safe mechanisms when you're going for your regular activities. So then finally you go for your hardware unit testing, then you go for your the integration and verification and validation. Okay. So we have seen the architecture of, we have seen the software planning, we have seen the software architecture design. And now we will see how this software unit is getting implemented with respect to a different ASIL category. Okay. Uh, and there are different methods you have for the software unit implementation. So some of those things includes one entry and one exit points, uh, subprograms and also in functions. So when I say double plus and single plus, accordingly, the importance has been given with respect to a different asset category. So the methods what you have, the first method is one entry and one exit point in subprograms and functions. Is applicable to all SLA, SLB, SLC, and SLD as well. And when you go for a method called where there is no dynamic objects or variables, or yes, there is online test during the creation. So it is applicable to SLB to SLD. And when it comes to SLA, you have this is been given a it's not given too much importance. It means only a single plus. Okay, but when it comes to double plus, this method has been considered to the greater level for the particular cell. So the next method is initialization of any variables, which from SL A to SL you are going to give more importance. So where there is no multiple use of variable names, um, and SLA is given single plus, the remaining SLB to SLD are given more importance. Or this method is very much applicable to SLB to SLD. Um, Similarly, to avoid any global variable or also we need to justify their usage. SLC and SLD are given. We can use this to the greater extent. And when you that, when you go for a limited use of pointers, where it can be negligible for SLA and for SLB and SLC, we can consider it depending upon the need. And when it comes to the SLD, we can use this method of implementing it to a greater extent. And the next method is no implicit type conversion with respect to the variables, what you consider for your software. So again, here you can use this method to some extent to SLA, and you need to use this SL when you consider SLB to SLD, you need to use the method called no implicit type conversions to the greater extent. Okay, and you have a method called where there is no hidden data flow or a control flow. You can use this method for your software unit implementation um, to the level from SLB to SLD, but depending upon need, you can even go for SLA. And okay, so the plus, double plus, and um, this indicate what is the indication of this? Okay, so it depends upon the usage of these methods into the particular SL level. So when I say SL A to SL D, you're going to use. Let us take one example of 180 and 180 point the programs and the functions. You are going to use this method when you're going for a software unit implementation. You need to apply this method to all the levels. Okay? And when I go for no dynamic objects or variables or else online testing, so here you're going to use this method from SLB to SLD, and you're going to use to the level, not to the greater extent like SLB to SLD for SLA. Depends on the need, we will be using it. And when I say a symbol like this, it is negligible. So we are not going to use the use of pointers when you're going for SLA software implementation. Okay. So there are some other methods where there is no unconditional jumps and no recursion. So when you're using this no unconditional jumps, when you go for a software unit implementation, where you will be using this method for all the SL category, SLA to SLD. And when you go for a recursion, where there is no recursion, and you'll be using this method when you implement the software unit. And this is been much more applicable for SLC and SLD, and it is given less importance. Or when you say less importance, it doesn't mean that we are not going to use this method for SLA, SLB. We are going to use this, but it based on the need basis. But when I give this symbol, we are not going to use. It's completely we are going to eliminate that particular method for the software unit.